Today we're going to look at conditional probability, and the learning goal for today is that we need to be able to determine the probability of an event given that another event has already occurred. So conditional probability involves looking at probabilities where one event has already occurred. What's the probability now that a different event will occur? So we're looking at events that will be linked. So the probability of an event A occurring, given that event B has occurring, is denoted by this notation here. We say the probability of A given B for this notation here. The probability of A given B. So essentially it's saying, what's the probability of A occurring now that B has already occurred? So what this does is it reduces the sample space to outcomes that are only in event B. So the probability of A occurring is everything that's in the circle here. Probability of A occurring is everything that's in this circle of the Venn diagram. But the probability of A given B is now only the probability that these events here will occur in the intersection of A and B, given that B has already occurred. So B has occurred, so that means we're only left with these few events in the intersection of A and B that we care about now. So the probability of A given B means that we are reducing the sample space down to just the events in B, and we only care about now what's the probability of A occurring. So the number of events there are the events in the intersection of A and B. So this formula can be used to determine conditional probability here. So the probability of A given B is equal to the probability of the intersection of A and B occurring divided by the probability of B occurring. But because the sample space for the probability of intersection of A and B, or the sample space of A intersection B and the sample space of B are the same, they will essentially cancel out. And those sample spaces, because those sample spaces cancel out, we can just have a look at the number of elements in A intersection B divided by the number of elements in B. So we can use this formula as a reduced and more simplified version of the formula above. So let's look at an example now. We can have a look at the first one here. It's a very simple Venn diagram and situation that we have going on here. So to determine the probability of A, we just find the number of elements in A and divide by the number of elements in the sample space. The number of elements in A is 5. So we've got the 3 plus the 2 here is 5, divided by the number of elements in the sample space. If we add them all together, we see there are 9 elements in the sample space. So it's the answer for A. B, the probability of A intersection B occurring is the number of elements in A intersection B divided by the number of elements in the sample space. So the number of elements in the intersection is 2 divided by the total number of elements. The number of elements in the sample space is 2/9. So if we look at C now, the probability of A given B. Probability of A given B is the number of elements in the intersection of A and B divided by the number of elements in just B. Because what we're looking at now is we're saying, I want to know the probability of A occurring given B has already occurred. So B has occurred. So we've reduced the sample space to B. B is all we care about now. So we can see in the intersection, now we care about A occurring because we want to know what's the probability of A occurring now that B has already occurred. So there are 2 elements that are possible to select that are our favourable outcomes in the intersection of A and B. The total number of outcomes in B is 6. So that means the probability of A given B is 1/3. Now finally we can look at the probability of B given A. B given A. This is going to be the number of elements in the intersection of A and B out of the total sample space which we have reduced to A. Because we've got A here is now the reduced sample space. A has definitely occurred. So A is the value that we care about now, none of these 4 values can occur. None of them can occur now because we've selected A. A has occurred. A has certainly happened. So the number of elements that we have in the intersection of A and B is 2, because we're looking at the probability of B occurring now that A has definitely occurred, and we divide by the total number of elements in A, which is 5. So remember, our learning goal for today was to determine how we can look at conditional probability, that is the probability of one event occurring given that another event has already occurred.